Hi everybody. In this video, we will discuss about design of digital filter using Chebyshev filter analysis and bilinear transformation method. So this is generally comes under IIR filter, infinite impulse response filter. To design infinite impulse response filter, two steps are required. One is define analog transfer function using Butterworth or Chebyshev, and transformation. Transformation means converting analog transfer function to digital transfer function. So first of all, we have to define the analog transfer function using Butterworth or Chebyshev. So the define using Butterworth I have explained in previous videos. In this video, I want to explain how to define the analog transfer function using Chebyshev filter, and later I will explain the transformation technique. And here I want to use a bilinear transformation technique. So to transform analog transfer function to digital transfer function, different techniques are used. From those techniques, two techniques are important. One is impulse invariant transformation method, and another is bilinear transformation method. So in this problem, I will explain this technique, bilinear transformation, and before going to the topic, we have to define analog transfer function using Chebyshev. Just to go through the given problem, the filter specifications are given here. The magnitude is varies from 1 to 0.8. It is defined, the magnitude is changes from 1 to 0.8 within the particular frequency range. The frequency range is from 0 to 0.25. So omega is 0 is here, and I am taking the omega is 0.2 pi is here, right? So up to this frequency, the magnitude response is varies in between 1 and 0.8. So that's why I'm drawing like this. The response is slowly decreases, and exactly this response gives this magnitude gives the 0.8 value at particular frequency, that is 0.2 pi frequency. This frequency is also called as passband frequency. So we can write as a omega WP here like this, passband frequency. So the gain of the system, the minimum gain of the system at particular frequency, that is a passband frequency. And again the response is changes and it goes to the zero, low pass filter characteristics, right? So from this point to this point, we have to consider as a passband. The allowable frequency range is called passband, and particular frequency onwards the complete in the signals are eliminated. That is explained by stop band. So stop band frequency we have to write in terms of WS, and according to the given problem, the stop band frequency is here how much? 0.26 is there. So 0.6 pi. 0.6 pi is stop band frequency. Exactly at this frequency it has magnitude. That magnitude is how much? 0.2. So write that value here. That means from here onwards the signal is completely eliminated. So this is comes under stop band. Stop band. So in between particular band is there. This band is called transition band. This band is a transition band. So now we are not considering that one. So just we have to take a passband frequency, stop band frequency. So according to the given problem, the passband frequency WP is 0.2 pi radians per second, and stop band frequency is 0.6 pi radians per second. Here I have wrote in terms of W representation. W explains the digital frequency. W explains the digital frequency because here we have to design the digital filter. So the maximum frequency is pi. Up to pi we have to take, because digital system or digital signal frequency response is defined from minus pi to plus pi. The complete period is 2 pi. So that's why digital filter analysis always we have to take from minus pi to plus pi, negative axis and positive axis. Here I wrote only positive axis representation. So the digital passband frequency is 0.2 pi and the digital stop band frequency is 0.6 pi. And here we have to design IIR filter. For that purpose we want h of s. H of s is nothing but analog transfer function. So immediately here we want analog frequencies. Analog frequency representation is done by omega symbol. So here I am writing omega p and omega s. These two are comes under analog frequencies. So here I want to find analog frequencies, pass band frequency and stop band frequency from the digital frequencies from the given specifications. That is depends on the transformation technique. And according to the given problem, here we have to use bilinear transformation method. So if you want to use bilinear transformation method, we have to apply pre-wrapping technique. Pre-wrapping, because in bilinear transformation it gives the one drawback. The drawback is frequency wrapping. To avoid the drawback, pre-wrapping is used. So before define the transfer function, write the relation between analog frequency and digital frequency using one standard mathematical equation. That equation is comes under pre-wrapping. Here 2 by t tan of 2 by t tan of w by 2. Now I want analog passband frequency, that's why I am taking here wp by 2. This is a pre-wrapping mathematical equation. So t is a sampling period. Easy calculation purpose here I am assuming t is 1 second. Is 1 second. And similarly I want right here 2 by t tan of ws by 2, stop band frequency by 2. So use this pre-wrapping formula and find out omega p and omega s. These two are comes under stop band frequency and pass band frequency. See, already I have calculated these values. Alright, so those calculated values I am writing directly now. The pass band frequency is 0.649. 0.649, just I am writing as 0.65 radians per second. Units are here, radians per second. And similarly, if you find the stop band frequency, this value is here 2.8. Approximate values I am writing now. Okay, so just try to calculate all these values. Then approximate values here I have wrote. One pass band frequency is 0.65 radians per second and stop band frequency is 2.8 radians per second. And later we want here lambda and epsilon, these two values also, lambda and epsilon, because according to the Chebyshev filter analysis, the order of the filter is explained by some standard mathematical equation. That equation is n is greater than or equal to cos h inverse. Here we have to take hyperbolic functions. Okay, cos h inverse lambda by epsilon. Lambda is a stop band parameter, epsilon is a pass band parameter, by cos h inverse omega s by omega p. Okay, these frequencies are analog frequencies. So omega s and omega p, these two are finished, and again we have to find the lambda and epsilon. And from the characteristics this value is equal to, from the standard filter analysis, this value is equal to 1 by square root of 1 plus epsilon square. And here this value, stop band parameter, is 1 by square root of 1 plus lambda square. So just assume these two values. Then from these two values try to calculate epsilon and lambda. So I am equating that one now. 1 by square root of 1 plus epsilon square is equal to 0.8. From this I am writing epsilon value directly here. So already I have calculated these values. So the epsilon value gives the 0.75. This is one of the repeated value, right? And similarly now I am taking one more parameter. 1 by square root of 1 plus lambda square is equal to 0.2 is there according to the given specifications, and from this lambda value is 4.8. Okay, so here I got the lambda value is 4.89 something, so approximately I am taking now 4.9. So substitute these values in this equation. Cos H inverse lambda is a 4.9 divided by epsilon is 0.75 by cos H inverse omega s is 2.8 radians per second and omega p is 0.65 radians per second. And again find out these values using calculator, and here I have calculated the value becomes here approximately 1.207. But the order of the filter expected value should be greater than or equal to this value, and order of the filter should be integer value. That's why here I am assuming the order of the filter is here 2. So finally we have got this order of the filter is 2 using Chebyshev filter analysis, right? And to find to write analog transfer function from the Chebyshev filter, again we have to find the poles location. So Chebyshev filter analysis explains the poles are located in ellipse shape. In Butterworth filters, the poles are located on the circle, right? So Butterworth filter explains all the poles are located on the circle, and Chebyshev filter explains all the poles are located on ellipse representation. So that purpose, here we have to write the poles equation should be like this. Poles equation Pk is equal to, write the epsilon the ellipse equation A into cos pi k plus j b into sin pi k. Pi k is the angle. Pi k is the angle. So A and B are ellipse parameters, because here if you take the ellipse representation on S-plane, so generally from the S-plane this is comes under negative real axis and the positive real axis, and imaginary axis, negative imaginary axis. Now all the poles are located on ellipse shape. The expected poles location should be like this and this shape, right? So we can assume the poles location at this positions like this, because it is comes under Chebyshev filter analysis. In Chebyshev filter analysis, all the poles are located on ellipse. So that purpose here we have to take the poles location. Pk equation should be like this: A into cos pi k plus j into b into sin pi k. So first of all, here we have to find what is the value, standard value of A and B. To find that purpose, again we have to find one more parameter. The parameter is mu. Okay, mu is also some of the coefficient. This coefficient is derived from the epsilon parameter, Fosman parameter, and this standard equation explains. So all these are the standard derived formulas are there. Epsilon inverse plus square root of epsilon power minus 2 plus 1. Okay, this is another parameter, mu parameter, because to find A and B values we want this value here, mu. Mu is equal to epsilon inverse plus square root of 1 plus epsilon power minus 2, or we can write square root of epsilon power minus 2 plus 1. Then epsilon value is there here. Epsilon value is 0.75. Substitute in this, right? So from that find out the mu value. So the expected mu value is here approximately I am taking. The value is approximately 3 now. According to the given parameters, the expected value is here 3. From this mu, find out A and B values. So A explains the omega p into, omega p is the passed on frequency, omega p into mu to the power of 1 by n minus mu to the power of minus 1 by n, right? So mu to the power of 1 by n minus mu to the power of 1 by n by 2, right? So A is a mu to the power of 1 by n minus mu to the power of minus 1 by n 2. Similarly, calculate B value. B value also explains the same formula, but there you have to write plus. So omega P into mu to the power of 1 by n plus mu to the power of minus 1 by n by 2. Okay, simple formulas here, simple formula is there. So A purpose you have to write there minus, and the B purpose right there plus. Then calculate these two values. We will get some parameters. So here from the given problem I got A value is 0.37 and B value is 0.75. So A and B values, these two. So using Chebyshev filter analysis, compulsory we have to find these three parameters mu, A, B, and Butterworth purpose these three are not required, because the Butterworth filter analysis explains that all the poles are located on the circle. There we can write the formula directly, e to the power of j pi k. But here we have to calculate these three values compulsory. So try to remember this formula and substitute the given values, then we will get this pole's location directly. And angle representation purpose, same formula is used. Pi k is equal to, right, pi k is equal to pi by 2, same equation, pi by 2 plus 2k minus 1 into pi by 2 into n. Then what is the k range here? K range starts from 1 and defined up to n. So the k value is 1 to n. And according to the given problem, the n value is here 2. So here we have to take the k value is 1 and 2 only. Right? So substitute 1 and 2 in this k and find out the angles. So we will get the angles, or pi 1 is 3 pi by 4, because already I have calculated these values here. 3 pi by 4, and pi 2 second angle is pi by 4, these two. So substitute pi 1 and pi 2 and A, B values in this equation, poles location, then we will get the poles values P1 and P2 values. So substitute these values, then we will get the pole 1. Pole 1 is minus 0.2, approximate values I am adding now, minus 0.25 plus j into 0.5, okay, 5 is enough, okay. And another pole, second pole is minus 0.26 plus here it gives a minus, right, because generally the expected poles location minus 0.26 minus j into 0.5, minus j into 0.5. So 90% we will get the poles location exactly conjugate poles here. Conjugate poles means sign of the imaginary party changes. So the expected number of poles are 2 poles. One pole is defined at minus 0.25 plus j 0.5, and other pole is located at minus 0.26 minus j 0.5. One is positive imaginary and the other is negative imaginary. Right? So from these two find out h of s. What is the standard formula for h of s here? H of s is an NLR transfer function. This h of s explains omega c by s minus p1 into s minus p2. Omega c is a cutoff frequency, and p1 and p2, these two are poles locations. So just substitute the poles location directly in this, and later you have to find the omega p also here, omega c. How to calculate omega c? Cutoff frequency is equal to standard formula Already we have discussed this is in Butterworth filter, omega p by epsilon power 1 by f. Right? So substitute this omega p and epsilon values in this, we will get the omega c, and substitute these poles in this equation. Finally, it gives the analog transfer function h of s. The simplified answer I am writing now here, 0.28 by s square plus 0.56 s plus 0.35. 0.5 s plus 0.35. This design digital filter or to find the digital filter transfer function. Write analog transfer function first. First of all, we have to write analog transfer function using either Chebyshev or Butterworth. And in this problem, I have explained using Chebyshev filter, and transformation method is which method? Bilinear transformation method. And here I wrote h of s, analog transfer function. Now we have to convert this analog transfer function into digital transfer function using which method? Bilinear transformation method. So now I want to erase this complete solution. Please try to take this. In bilinear transformation, one standard procedure is defined. Replace s is equal to 2 by t into 1 minus z inverse by 1 plus z inverse. Or if you want to write in terms of positive powers, just write this one 2 by t into z minus 1 by z plus 1. Okay, so this complete analysis we have to replace in which function? H of s. Okay, replace in h of s, s is equal to this complete equation, then we will get the complete h of z here. That part also you can write like this, h of z is equal to because bilinear transformation method, s is replaced by this formula, then it gives the complete h of z. Now wherever the s is there, replace that one, then we will get the h of z. So 0.28 divided by s square. So 2 by t, let us take t is equal to 1, already we have assumed t is equal to 1 there. So 2 by t into 1 minus z inverse by 1 plus z inverse whole square plus 0.5 into s again write this one, 2 by t into 1 minus z inverse by 1 plus z inverse plus 0.35. Let's simplify this. So now I will write the simplified answer here. Just try to simplify step by step analysis, take LCM and finally write simplified answer, simplified digital transfer function. Now writing that h of z is 0.05 into 1 minus z inverse whole square by, just take LCM of the above equation, then it gives this complete expression here, by 1 minus, so already I have simplified this value, this above solution. I simplified this, that's why I am writing directly 1 minus 1.602 into z inverse plus 0.73 into z to the power of minus 2. 0.73 into z to the power of minus 2. This is a complete digital transfer function. To design the digital filter, digital IIR filter, first of all, define analog transfer function using Butterworth or Chebyshev, and later apply transformation techniques. Two transformation techniques are there. One is bilinear transformation technique and another is impulse invariant transformation technique. In this video, I have explained using bilinear transformation. So if you want to use bilinear transformation, use this pre-mapping formula. Compulsory we have to write analog frequency from the digital frequency using this equation. And if you want to design impulse invariant transformation method, Directly we can write analog frequency is equal to digital frequency, or we can write omega s is equal to ws, because impulse invariant method comes under linear transformation method. So that explains analog frequency and digital frequency, these two are directly proportional. So both are approximately equal. General equation is we can write like this: W is equal to omega into T. Right, T is a 1 second, that's why I am writing analog frequency, digital frequency, both are equal. So if you want to apply impulse invariant transformation method, write analog frequency from the digital frequency using this formula. And here I have explained this pre-mapping technique using bilinear transformation method. So, so finally write H object. So this is the complete procedure. It takes some time, and use calculators, find out exact values.